Good afternoon, everyone, and welcome to this webinar, which we organize in collaboration with ONDA. Before kicking off, I would like to wait just for 1 or 2 minutes because we are still waiting for a few participants. So if you can bear with us for 1 minute, and then we start the presentation of Frank. So I will mute myself now for 1 minute, and then I hope you bear with us. Thank you. Okay, let's not keep you waiting for that long. So we will start the show of this afternoon. My name is Martijn Seiger. I will be your co-host today. And as said, we organized this webinar in collaboration with ONDA for Education, part of Serco. And the presenter of today is Frank Ranera. And he will tell you and inform you about the services which ONDA develops, and also give some insights in how to work with satellite data, which gives me the opportunity also to announce again the webinar. No, it's an online training which we will organize the 14th of June. And this will give you the opportunity to work with real satellite data, to develop your own case studies, and to get a proper training on how to use Sentinel-5P datasets, which is for atmospheric monitoring services. So if you have the opportunity to follow this intense course of 1 day, then please do so. Go to the webpage of Groundstation.Space for registration. You will find the announcement. I will also put it on LinkedIn. And we hope you join this as well. And we're looking forward to collaborate you not only under the heading of the SKIES project, which is a European funded project, but also for the future. So in case of any questions during the webinar, feel free to put them in the chat. We will moderate the chat. Frank will anticipate on your questions, and in case you want to have a question afterwards, then also feel free to use your time for this. So enough introduction. So Frank, may I give the floor to you? And thanks all for joining, and we hope you enjoy the lecture by Frank. Frank, it's up to you.
Okay. So I hope you can see my screen. Many thanks, Martin, for these words and for welcoming us in this training. That's the start of our cooperation. That's the start of the training that will explode, let's say, in June 14, 16. But this is the first step. It's a smooth step. I won't make any demo. I won't make any concrete usage of the data, but I want to give you a context, information around the solution ONDA DIAS, the platform, the cloud-based EO platform, explaining you the context, explaining you why, how we have developed it, what is it offering, what you will get in hand during the training, which type of application or how you can use it. It's basically an overall information I want to give. But first, I will present myself. My name is Frank Ranera. I'm working for Serco Italy. I'm in charge of developing the Serco digital solution, and namely the Copernicus ONDA DIAS. Not in systematically pushing for innovation, but in answering to the needs of the user, wherever they are. And we'll also give some explanation of this profile of a user that we have, but also balancing this answering to needs with the new technology, these new elements that we have, and training like this one that we are organizing now, and that will be very concrete in June, help to reduce the barrier, to reduce the technical frontier that still exists, raise the awareness, raise the confidence in using such a technology. So let me start for the beginning. I would like to put this small. Okay, great. So first of all, what is the DIAS? That is an acronym that you will see several times in this presentation and in the coming weeks, and maybe that you have seen already in the past. Data and Information Access Service, which is basically the answer of the European Commission to the big data challenges. What does that mean? We have a massive amount of satellite data today. And not only today, by the way, it started in 2014 with the first Sentinel data, with MVSat as well before, with MERIS. This concept of free and open data make that a consumer like you, end user like you, had access to this massive amount of petabyte of data. And one question raised, mainly from the community of user, is how can we exploit that? How can we leverage that? We cannot download, it's too much space. We need high computing power to make our analysis, because it's a huge time series of data. We come back on that as well. So it raised that point. And at that time, I would say 2015, maybe before, the European Commission and the European Space Agency start to investigate on the best way to answer to this challenge. They look as well what was done in other territories and the US, obviously. And the solution is quite natural, is the use of the cloud-based EO platform. So that's the concept of the DIAS. So the European Commission put the money on the table and charge ESA to manage this DIAS contract. So what we provide today with the platform is, first of all, access to massive amount of data, access to infrastructure to process this data. It is what I put here with our data in this scheme on the bottom of this slide. We provide all these elements. It's not just the data, it's the overall platform, data plus possibility to exploit this data. You bring your algorithms, your value added, and we develop, or you develop, a real application that serve the citizens, that serve the community. That's the logic of the DIAS. There is something, I wanted to move my presentation. Okay, perfectly. That's the concept. So how we implemented it. First, there is two words I want you to keep in mind during my presentation that are quite important. Is the one on the right-hand side here, automation processing and virtualization. That's quite important because automation processing means that we are not anymore downloading the data or receiving the data from a DVD or a tape and put it on our local computer and processing just one data. When we get the result that we want, then we pass to the other date or the other data that we may have. It's not anymore like that it works, because then we cannot really exploit or leverage the quantity of data that is available. So what has been done, obviously, is to make some processes that repeat the analysis regularly as you want. And each step is automatic today. Selection of the data according to parameters like the angle of view, the cloud coverage for optical data, any polarization or other parameter regarding the SAR data. But I mean, you can filter the data either if you want in your catalog, download the data or process it remotely to generate the information that you want. Virtualization means that today you don't need to have a computer really to do that. I mean, a powerful computer. As I told you, we are in a cloud philosophy, so you can leverage the power of the cloud in terms of computing power, but also in terms of storage, in terms of automation, of orchestration, we used to say, and I will come back to that a little bit later on. So the mindset is changing today. With the massive amount of data, we have something that is completely different with respect to, I would even say, 5 to 10 years ago. There is this two game changer that the Copernicus program put on the table. First of all, is the data are free. This was existing a little bit before the Sentinel data, but it comes from Europe, even if we had some Moody's data that were for free as well from US. Nevertheless, this free and open philosophy, this is the Copernicus philosophy, is exploited completely by the Sentinel data. So the massive amount of data is all for free for everybody, not limited to European citizens. And the other elements is the fact that the data are acquired systematically on land. Maybe not over the full world, but let's say that over Europe it is the case. This means that you have a data each 6 days for Sentinel-2. There is a lot of data that are available now thanks to these two elements. Before, and the VHR data, that are symmetric data, they are not using this philosophy. They are under request. No, they are very precise for spatial resolution. They are very limited spatial surface, but they are on demand. Conversely, Sentinel data are systematically over land area. Okay, that has been the two game changers. So we have free and open data, we have systematic acquisition over land, we have automation processing and virtualization. Oops, okay. So that's for the concept and how the DIAS has been implemented. Now let's see, what do we offer? What will you have when you will access to the virtual machine? First, the data, that's the first pillar. So we are offering, you see all this data set. Sentinel-1 is radar, Sentinel-2 is optical, Sentinel-3 is optical, Sentinel-5P is the one quite important for the air pollution. You will access to them. We do also, maybe just on this satellite, family of satellites, this is the number that we have. You see 41 petabytes of data are currently stored on our storage capacity. It represents 67 million, more than 67 million of products. And that's number that are like 12 terabytes per day. So 12 terabytes per day, for those of you that are quite familiar with this unit, will understand what does it means. For the others, I will say that it represents the 8 of the Eiffel Tower of DVDs that we receive every day. Every day we receive new acquisition of the Eiffel Tower, and we have to manage that. Quite important to understand as well is that we host all this data in our premises. We do not rely on third party. We don't have to ask the data. If you ask for data yourself, we don't have to rely your request to someone else or to shift your request to someone else. We do have all the data in-house. There is no third party contribution, which is guarantee us to influence the performance when we have to access the data. If there is a problem, we know how to manage it because we have everything in hand. MVSat, Landsat 8 also, well, Landsat 8, yes, it's a new mission, it is a mission that is running now, but MVSat is not running anymore. Why we do offer this Landsat family and MVSat data? Because we wanted to extend the archive of data. With MVSat, that was launched in 2002, if I'm correct, and it's not active anymore now, but we do have a continuity of data starting from the year 2000. If we had the Landsat 8 and Landsat family product, then we do have even a larger archive. So for those of you that are interested to monitor trends, tendency, how a surface, a territory has evolved in time, you do have something like more than 20 years, even 30 years of data to make your analysis. And we do offer as well these Copernicus core services. You see Copernicus Marine, Land, Atmosphere. These are data product, more than data product that are generated on the Sentinel data by the industry under the European Commission and ESA managed services. So all this data represent the portfolio that we are offering. That's for the data. Once you get a VM through ONDA, you get access to all this data. But we understand as well that it's not enough. Many of our customers said, okay, with the Sentinel data, we can do a lot, but it's limiting our services. And some of them, I would say most of them, are developing commercial services. So they say we need VHR data. Some of them were already in touch with this provider, so they don't need us. But some other, they were new in this field, they were startups, they were newcomers, and they wanted to optimize the interface. And they say, we want just one interface. We don't want to multiply the interfaces with just one. So that's the ideal approach. And they say, okay, guys, we will do the agreement with this data provider. So we have signed it with Deimos, with Maxar, with ComSat. And what was interesting us more than having the data available for our customer, it was the way to access the data. And with respect to Maxar, we have this capacity to use API. So recording the automation processing that I was mentioning before. If you use APIs to download, to identify, download, or even access the data to process it, then you can use similar APIs. You can upgrade your code using these Maxar technologies to access this data. So it's like an upgrade of the code of the automation processing, but extend the capability to VHR data. That's the digital library I'm mentioning here. Obviously, this agreement gives you archive and new acquisition as well. Both type of data or type of request can be managed. That's for the data. Sentinel, very high resolution. Now, the other pillar. The other pillar is the cloud instances, as we said. It's basically the component of the computer, the virtual computer that you will use. Here we are relying on our partner, OVH Cloud. It's a French cloud provider, quite well known in Europe. It's extending all over the world. And it's providing a complete, quite complete and heterogeneous range of capabilities. And I listed the three main pillars that they propose here. And each pillar is composed by various virtual computer. And you can see that the difference is with respect to the number of core, to the RAM, to the local storage. When I say local, is the block storage, we used to say, is the disk attached to the virtual machine. So you can have a model, let's say, and you can see B2, C2, R2 in the surname of these models, and you can play with that. And I will come back on that and on how you can modify that. So this for the virtual computer, but it's not limited to that. We do offer as well all the portfolio that the cloud provider is offering today. This means the GPU has powerful virtual machine, mainly dedicated for artificial intelligence, machine learning process. The storage is key in our world. As I told you before, we are receiving massive amount of data. When you will do some activity, you may produce also a lot of auxiliary data, a lot of end products. So you need to store them. So storage is important, and we have different solutions that meet the needs according to the volume that has to be produced. But something that is important, first of all, some of you may have heard about the S3. Now, this is Amazon. This is quite a standard today in the market. So all the solutions that we are providing here in terms of storage are S3 compatible, which is quite important for someone who is already making some works on some storage from Amazon or other places, and they need to maintain this S3 compliancy, allow you to pass one environment, Amazon, let's say, to another environment, ONDA, without any problem. And this interoperability, I will come back to it because it's quite important, the way to pass from one environment to the other because you are using standard. But let me complete with the storage. That's an important point, is also the sensibility and the security around the storage. When we are putting elements on the cloud, we always wonder if it is secure, if no one will copy it. What about algorithms and code, with respect to intellectual protection rights, IPR elements? So that's quite legitimate, and we fully understand that. It has been addressed at the early stages, I would say, by the European Commission. And we do have already some standard ISO, ISO-like standard that exists in terms of security around the cloud. Obviously, we are fully compliant with this standard. It means that whatever you're putting in the cloud, that's your property, is completely close to you, or you decide with who you want to share it. So it's guaranteeing the confidentiality, it's guaranteeing that no one else than you can decide who can access to your data. It is important as well, in case you have license protected data there, that no one can copy it and use them. So this element is something I wanted to insist on. Kubernetes, I mention it here because that's something that we see more and more today. What is Kubernetes? It's a kind of orchestrator of tasks. Many of our customers, they do not have a linear way of working. I'm thinking to the one working in agriculture, for instance, that during summertime in Europe, they will have peak of work, peak of charge, because, okay, the crop are there, they're ready. There are a lot of monitoring activity that are done at that time, which is not the same during autumns or winter periods. So the way that you can automatically manage your infrastructure is done by a software like Kubernetes. It will, according to criteria that you set up yourself, decide how many virtual machines, how many storage is needed to make your job performing perfectly in a cost-effective way. So that's a solution that we propose as well, and I understand that can be quite new. And we have a service, a managed service in Serco that help to set up and also to manage this type of services. So that was for the cloud pillar. I talk about the data. Now I talk about the cloud pillar. That's the two pillars. Let's talk about the bridge between these two pillars. That's the APIs, the famous API that we say. We are using standard APIs. OData, OpenSearch, they are very well known in the world of the cloud for interoperability. It's what I was mentioning before with the S3 compliancy. That's for storage, but also for searching data, identifying data. We are using this standard that makes you able to export your code that you have developed in an environment where these APIs are supported as well, and to copy it in an environment like ONDA, or vice versa, you can develop it in ONDA and export it to another place then, because we are all relying on this standard. I want to say that it's not the case for some platform. Google, for instance, they are using their own library. They have a lot of very powerful elements, but they are not supporting this open approach, where you can share everything. They are their library, and if you want to export a code that you have developed under Google Earth Engine, you cannot export it like that, because the library that you use are just understandable within the Google Earth Engine platform. So that's what for the interoperability of ONDA DIAS and the API that we are using. Then I will go to, still on the left-hand side, this Horizon Web Portal. I told you before as well that you can manage your infrastructure whenever you want, as much as you want. This means that you can upgrade, increase the computing power or the storage, or decrease it whenever you want. If you're using Kubernetes, they can do it for you, but you need to know how to configure it. But if you're not using Kubernetes because you don't need it, then there is also the manual approach. There is this web interface on where you can decide whenever you want to change the configuration that you set up. You can change the virtual machine if you consider that it's too powerful or not enough powerful. You can increase the storage and so on. We do have two payment mode. I know we are in a training and it won't be paid, but I think it's quite important to have this dimension as well. The data for free, VHR data are paid data, and the cloud component are paid elements as well. So that's the only paid element in the platform. So let's say that if you are using this Horizon Web Portal here, when you create a virtual machine, you can have it either in hourly mode or in monthly mode. It means that each hour started is due, each month started is due. You can select the best way for you. I mean, if you work on one shot like that, you just need hourly mode. But if you work, maybe you will work for 3 months, then it's better for you to go on a monthly mode. But that's a way to manage. You can manage everything: the content, which virtual machine you need, which disk you need, but also the paying mode, how it's the best adapted for you. That's for the autonomy and the flexibility with the platform. It's basically the cloud philosophy. But there is one API that is quite interesting, and that is property of ONDA. It's what we call the API ENS, the Elastic Node Server. So this API allows you to analyze a Sentinel data without having to download data on your virtual machine or on your local computer. You can access it directly from the virtual machine. You will dive into the product as if it was in your computer. You can go to the spectral bands that are of interest for you, and you can apply a process. I give here an example of the NDVI. You see, using just the code and the API, you can automatically identify the data that are of interest over your area of interest based on some criteria: temporal window, specific product type, angle of view, cloud coverage. I mean, there is various filters that you can set up, and you can put that on your code as well. So the machine will automatically, the code will run and automatically check the catalog. Once the data is identified, this data will be listed, let's say, and you can either download it on your local computer, on your virtual machine, local disk of the virtual machine, or you can, using ENS, you can dive into this or select the bands in your code. Not manual, automatic. In your code, you go to the spectral bands of interest for you, only read needed bands, is what is written here, and you can compute the analysis. Here I give the example of the NDVI and the vegetation index. So you can apply the formula and generate for each data that you have the NDVI and store the output product. And on a weekly, bi-weekly, monthly, bi-monthly, whatever the frequency that you need, make your own analysis over your feed, apply your color code as I did in my example here. So that's a way of working remotely. Sometimes it's quite powerful. Sometimes persons prefer to have the data set in-house. It's better for them to manage the data set, to come back on it and so on. So there are various approaches, but my message here, there is a way to access remotely to the product. So we have seen the pillar of the data, the pillar of the cloud component, the bridges, the API. And I want to insist on the API because many of our customers used to say, I just trust on API. I don't want to see any button, but some of them are like that, not all of them. I want just to emphasize here independent benchmark that has been requested by ESA, that has been done by two companies, Privia and Teradue, which are absolutely not linked to the DIAS contract, but they are users, they are quite mature in using this technology, and so they make a benchmark, in terms of performance. Where do we stand? And I think it's quite relevant to show you the result of this. That was published in January 2022. And generally, they make an analysis each 6 months. So we expect to have maybe another one by June or July. The message here was quite nice. The most complete collection of Copernicus Sentinel data with consistently very good overall performance in accessing the data, in downloading the data. Also, the time gap in between the data is acquired by the Sentinel satellite and is then available in the ONDA catalog. And this is just the time to be published by ESA. As soon as the data is published by ESA, then we take it and we put it available in our catalog. Service support and documentation to be improved. So that was in January 2022, and we already demonstrate to ESA that we have improved here. And by the way, this training, and I think the one in June 14, June 16, will be also a good example of the improvement and the type of support that we want to give. So now let me describe a little bit how we develop downstream services. Downstream services here means application. So in Serco, we are not really developing downstream services. We decided to provide the tools to people like you, to SMEs, to develop commercial services, to industrial partners, but also to I would say, major player for more ground segment approach, not downstream service, upstream or midstream services. But go back to the downstream services, what we do. First, we have a lot of assets. It means that we have the computing power and we do have the data. Then what we decided is to shape new services that respond to the needs. I will start for the first one, the big data. As I told you, we do have a massive amount of data. We have the engine to process this data. So we generated what we call the Argo service. Argo service means the Copernicus analysis ready data. Many of our customer needs atmospheric corrected data that are not systematically provided by ESA. They may need coherence product. Coherence is a change on the surface in between two SAR acquisition, radar acquisition. So there is many data that are needed by our customer, not as output, not as final products, but as input for their processing chains. So we decided to avoid, because the request came very often from our customer, we decided to produce this data and to store this data on our own premises and not charge to the customer. It means less storage for him. So we have produced this data set. Let's say that we do have the capacity to generate it with the customer, according to the area of interest he's interested in, according to the temporal window he wants. We produce this data on demand. We do have the processing chain already in place to do it. That's what we call the Argo service of the CARD, the Copernicus Analysis Ready data. Then what our customers are doing, like you, for instance, during the training, like what you will see, is that they are taking like a puzzle, all the elements of the cloud instances that we do offer, and they are built it without support for those that requested it, without for those that have the experience to do it by themselves. But they're building the architecture, the environment that they need to process the data. Generally, that's the place where they put, here you can see, the artificial intelligence algorithms that they have developed. I mention artificial intelligence here because there is a lot of customers that are using this type of algorithms and analysis, but obviously, whatever it is, the code can be put there. And then there's the automatic processing. Then we have the virtualization. Virtualization is generally end user is not really interested in seeing a product. What you want to see is information, is a report. And that's the information. Either we produce a map, either we produce a data end product, a value-added end product, and many often we produce report that is combining all the analysis that has been done. So that's the type of information that is providing. That's the way that we responded to the expectation of the downstream market. I want to give some information or more detail about the type of customer that we have, but not only here. The example of the agriculture. Agriculture is well known. There's a lot of expectation, a lot of competition as well. So we started to apply the model that I showed in my previous slide to this customer. First, Flanders. This is a request to help the paying agency of Flanders to move from a manual check of their agricultural parcels, to check the claims of the farmer. We are here in the middle of the common agricultural policy. Okay, so we did the model that you have seen before for them, and that has been extremely successful. And we won this first prize of Digital Society Award in December 2020. Then Isa asked if we can do the same for Wallonia, so we're still in Belgium. We were thinking that, okay, it's just a copy and paste of what we have done. Well, that's not real life. Real life is that we have to adapt to the specificities of each customer and the way of working. So we had, yes, a base that was quite robust, but we have to customize it, to tailor it. At the end, it results to be something quite different with respect to the initial model. And again, here, it was not the same level of maturity. So it was more, demonstrating the robustness and the maturity of this technology for moving from on-the-spot check, as they say, to automatic check based on satellite. This was in 2021. Then in 2021 as well, the French government issued an invitation to tender to make the same exercise, the same approach, controlling the agricultural parcels for the cap monitoring. But they did it from an operational point of view. They are moving in 2023 from the former way of working, controlling a small number of claims, using people on the field and checking whether the claim is correct with respect to what has been seen from satellite. A very small number of parcels are checked with satellite, 5% of the claims. But what I want to emphasize here is that these two experiences that we built using ONDA, using all the satellite data, give us the credibility, the competencies, and the experience to answer to this French public ITT. And it's basically where you stand, learning how to use these tools, building applications, getting experience and awareness of what can be done to maybe tomorrow get a commercial contract or creating your SME, your startup, or building research in some fields, leveraging the technology. And Serco has been awarded by this contract. That's quite important because it's the first member state in Europe that is issuing such a contract, and to move from let's say manual check of the agricultural parcels to a 100% satellite, 100% automatic approach. And this is sponsored by the European Commission. So we expect to have all member states moving in this direction in the future. That's an example also, still staying in the agricultural thematic. This is quite interesting to understand also the type of customer that we have. And I give the example here of Agricolus. Agricolus is a small company. I would say it has been created maybe 3 or 4 years ago in the field of agriculture. And their scope is to help farmers, like the old man that you can see there, in using latest technology to improve the production, to improve the management of their agricultural cells. And they are combining various sources of information here, satellite, drone, meteorological, in situ, chemics as well in the field. So they have a lot of competencies and they combine that in one single interface to generate the value added. From us, they are using the computing power, the storage, and the family of Sentinel-1 and Sentinel-2 products. I would say this is quite important because this farmer will never have used a satellite or this technology if a company like Agricolus have not developed such a service. And Agricolus will not exist or will not exist if ONDA DIAS was not there to give them the tools to develop their application. And by the way, these applications can be used through tablet, cellular phone, computer. I mean, there is a company of 20 people that is leveraging the latest technology to develop applications. We have many examples like that. But what I want to insist here is first, we have a model on the right-hand side. You can see this ONDA for Education logo. We understand that we need to reduce the barrier, that we need to raise the awareness. And it's exactly what this training is supposed to do. Maybe you are expert in using satellite data. Well, we want you to be expert in using satellite data through digital platforms that to leverage this new approach. New, I would say 5 years ago, maybe for those that use Amazon and Google, maybe even more than that. But it's good to know what are the tools that are today provided by the European Commission and the European Space Agency for such activity. I give some examples. Ricolus will talk about it. You can see IREA that have developed also a ground motion service, which is not an innovation. We already do have such a model existing, but the innovation was the scale. They are doing it in continental scale in a very short time frame, in a very cost-effective way as well, thanks to the model that is in place with ONDA. We have Acrotech and WASD. Here we are in the emergency management world that are serving UN agencies with information regarding flood impact, extent of the disaster on specific countries. And they created a platform to do that, relying on our data, on our cloud instances. ENGV also, which is the volcanology and geology public office in Italy, that is monitoring a lot of hotspot area with respect to volcano, with respect to the landslide, using our platform. So that demonstrates the robustness and I would say the right level of performance that we have with this high demanding customer. I may have examples like that, and we can spend hours and hours to show that, but I think that's not the scope. What I wanted to emphasize maybe is the tendency. What I am observing today. We saw that our last customer, the last request we receive at least, and some are evolving towards that, some are starting with this model, is the digital twin, is digitalization of targets and offer services based on a graphical interface. I give here the example of G-Sky, this company that won the first prize in the ESA FIWIC Hackathon in October 2021. They have developed this 3D virtual model using bridges or infrastructure. They were using infrastructure. What they did is they use satellite data to identify area where the bridges are existing, the infrastructure is existing, and they simulate the evolution of this infrastructure according to critical items. Now, it can be the temperature, the wind, landslide, earthquake. They use not only satellite data, but in situ sensor as well, as you can see in this photo, for instance. And combining all this information and playing on this parameter, they can simulate the evolution of the bridges. That's for a bridge, but you can think the same for many, many infrastructure. I'm talking also to gas, fuel pipe, water pipes. There's many elements today that can be subject to that. And the message I want to pass is that the tendency I'm observing in the market is this digital twin, simulating on a virtual 3D model some target and playing on the evolution. And by the way, ESA is developing today the digital Twin Earth and Destination Earth. These are program and projects from ESA and the European Commission, that are really addressing that, but not on a target like that one, but more in a global way, the world. Okay, I will start my presentation to give some space to the Q&A if there is some, but I want to emphasize just what will happen in the future. So we have the training in June 14, June 16, and you will have another webinar on the June 14 given by my colleague Georgia that will be much more concrete than me. Demo, much more precise on how you can use the tools and how you can access the data. Real demo, not a generic presentation like that one. What you will have in hand is the infrastructure. Each of you will have a virtual machine with these characteristics. We decided to go with Linux and remote desktop because for those of you that want to work with Linux, you can work with Linux. For those of you that prefer to work on a Windows environment, you have a remote desktop and a window-like desktop, so you can use it as if it was Windows. There's pre-installed software, Snap, QGIS, Jupyter Notebooks, and the instructor will use exactly the same virtual machine than you. So you can repeat perfectly the exercise and the elements that she will show. Obviously, as soon as you have a virtual machine, you have access to all these elements I'm presenting, above all, the volume of satellite data that I've just mentioned before. The instructor, Georgia, but also some colleague, maybe will be with her, there are people working in the European Space Agency. They used to work with satellite applications, Sentinel-based satellite application. They used to work with this SNAP, QGIS, and maybe other tools. They do have a strong experience, obviously, also working with ESA. Dedicated assistance. During the training in these 3 days, you systematically have someone that is there for you. Maybe not the full time. I think we agreed for 2-hour slot per day, but something to cross-check. Anyhow, you will have an email you can write to if you're blocked, and you will have a support either for a scientific perspective. Georgia and colleague will be there. Also for ONDA DIAS in case there is problem of accessing the virtual machine and accessing the data. The post-training support is there. 2-hour webinar for a Q&A session, and that will be done 2 days after the live session. I think this will be consolidated when Georgia will take over on June 14. I'm just showing some how to activate the virtual machine, but I don't think it's very meaningful and relevant here. I just want to show that there is various models and various way of accessing the virtual machine. You will be in the model Linux with remote desktop. This means on the right-hand side, on the bottom right-hand side, that will be the interface that you will get. Basically, just double-clicking on the one directory, you have all the data available. Okay, that's another way. Okay, you will have all that. But remember that one day or another, if you come with us to develop some application, the support is still there. It will always be there. The training is there to, again, reduce the barrier, raise awareness, raise the confidence, and so on. But the support always exists. We do have an email, you see, this ONDA DIAS help desk, which is systematically there. I mean, we are a commercial service as well, so we are committed. We are for results, we are committed for performance, and we have some SLA, service level agreement, with the customer. So this support team gives what we call the level 1, level 2, level 3 support. Whatever the problem you have, we have someone to answer to it. We do have user guide. So you can go on that website and you can already have some information of the API on how to use them. Various information are available there. And then we are thinking also to distribute this video that help you show you how to search data, how to download data, how to exploit data. It's basically, we have to see if we can share that because unfortunately they are not yet branded. It's an administrative issue, but that's something that we are working on. And will be hopefully solved before June 14. Anyhow, all these elements will be also addressed during the June 14 training or webinar, sorry. And that's all for me. So I haven't been too long. I'm very pleased to answer the question.
Thank you, Frank, very much for your presentation. Let me try to ask a question to you. You spoke about the core missions of Copernicus, the Sentinels. What other data from contributing missions? How are they in the DIAS, or does the application developer has to manage it on their own?
Sorry, I missed part of your question. I was trying to put the video, but I don't know how I can put my video again. Yeah, okay, I found it now. I want just to put the face. Sorry, I just missed a part of your...
That doesn't matter. The question is, you mentioned the core missions of Copernicus. What is about the contributing missions? So what happens to that? Is it also part of DIAS, or is it something which has to be developed by the application developer?
Yeah, when you mention contributing mission, you mean a third-party mission that can be offered by ESA or other mission, right? When you say contributing mission. Well, actually, the DIAS is focused on Sentinel data and the data that I've show. We are on so the Copernicus and the VHR data is something that we added. So the commitment that we have from a contract perspective is to just Sentinel, MVSat, Landsat 8, and the Copernicus core services. So contributing mission or other mission outside these ones need to be managed directly by the participants or the ONDA customer.
Okay. Okay, then maybe a follow-up question from my side is we have as an audience many astronomers, PhDs, and can also be deep space data be integrated, or is it the same answer only?
Well, I have to be very clear that you can add any data that you want, okay? I'm just saying that if you want to access the data through APIs or stuff like that, then no, from ONDA object storage, ONDA catalog, you will just access to Sentinel data. But obviously, in the disk that we propose, you can upload any data that you want. It means that then you will have in your environment, your cloud environment, you will have the data set that are stored on ONDA, but also any other data set that is coming from yourself. So we will have all this data available. What I'm just saying is that if you want to have maybe this additional data that you were mentioning, then you have to copy them in the local disk of the virtual machine.
Okay, thank you. All right, so are there any questions from the audience? Please put them in the chat, or then if not, Georgia, do you have any questions?
I see no questions yet from anyone. You can always raise your hand as well if you want, and we can unmute you and we can have a discussion. I think the presentation was very clear and interesting, and I guess that we will share afterwards. Yes, I just see a hand raised from Andre, so.
Yeah,
okay.
hi. Thank you very much for the nice presentation. Besides the data support, the infrastructure, also the Kubernetes is very much appreciated. Do you also offer, upon request, already developed APIs or applications processing modules or something like this, or they can be taken from somewhere else and then interoperable within ONDA?
What we have done is to concentrate in the data access, in the data selection. We did not develop value-added information or value-added services. I would say that first it has been a strategical decision. You know, when we started this contract in 2018, we decided not to be a competitor to our customer. So some of them can see us as, hey, you are also developing the same service than me. Why I'm going to you? So we wanted really to focus on our mission to boost the ecosystem, to boost the usage of the platform. And so we decided not to develop third-party services or value-added services or downstream services. That's why from 2018 to 2021, actually now we have built a lot of relationship with SME, with startups, and many of them come back to us saying, do you agree to integrate our service to your platform? So that's something that we are currently analyzing, and that for sure in 2022 and beginning of 2023, we may offer services. But at the time being, we are not providing examples or code that you can reuse to produce information. Again, what we are providing is Jupyter Notebooks examples on how to access the data and to make it easy and simple. How to filter data maybe using Jupyter Notebooks. So that's elements that will be shown, I think, in the webinar on June 14, or at least addressed at that time. But like an NDVI production or element like that, or target recognition, which is artificial intelligence based, we are not offering yet this type of services.
Yeah, no, thank you. Yeah, the question comes also because somebody that would start with start from scratch, they would need a little bit of guidance. But I think also there's a lot of information in regards to Jupyter Notebooks, and then this is something that is already embedded in the system. So would it be a problem to? I mean, the system is interoperable, as you said, can be accessed through Jupyter Notebooks. But I was more curious about Absolutely. If you started a marketplace like other DIAS providers did in the past. But yeah, you answered already this question. Thank you.
Again, a marketplace, it depends on the definition we give to a marketplace. I think it's quite heterogeneous as well. What we decided to do is to give a showroom. We call it more than a marketplace, a showroom. A showroom means that any ONDA customer can show what they're doing, describe it, and put a link to their services. That was at the early stages, still existing. It's good for us because it demonstrates that the platform is used. Good message that was needed towards European Commission and European Space Agency, but it's good as well to the SME startup because it helps to, the famous fast to market, because we do have an ecosystem around the platform driven again by European Commission ESA. There's a lot of promotion, a lot of people looking to it. So it's good for SME or startup to promote these services using this fast to market channel. That's what we did in terms of marketplace or showroom.
Okay.
Thank you very much. Appreciate it.
Frank, there's in the chat there's a question. Maybe you can address this.
So I'm opening the chat, but I cannot see it.
In questions.
I can read it for you if you want.
Okay. I can see now. I can see. Or would you? Sorry, wait a second. Well, if you can read it, it will go faster because I just see a part, I think. So if you can read it, yeah, Georgia, please.
Yes. So the question, because it has several parts, so I will start part by part. Do you also have a pay-per-request API that downloads data instead of working in the virtual machine, in case you only need to download the data once or maybe once a year?
It's even simpler than that. There is a free of charge approach here. If you use the API, ONDA API is free. Access to the catalog is free, so you don't need to pay anything here. You can use the API to check if the data is existing. You can even use the catalog manually. I mean, if it is a one shot or something that can be managed manually, and you can download the data. Everything is free here.
And
the only paid element of the platform. Sorry, I just want to complete the answer. The only paid element of the platform is the VHR data, if you want to access this data, and the cloud elements if you want to have a virtual machine. But accessing the data, downloading the data, and when I say data here, I'm referring to the Sentinel data, everything is for free.
Okay, thank you. And just to complete the question, or would you, in that case, would it be better of using something like Google Earth Engine?
I told you, Google Earth Engine is a wonderful tool, I would say, and it's something that I enjoy. And but is a proprietary system. I remember once when the Google Earth Engine started to exist. No, I think it was many years ago, and there is an ESA meeting that was everybody was talking about that, and there is a French laboratory that say, okay, guys, if you use the Google engine, but tomorrow Google decide to switch off something or to change something, it's like if they close our laboratory and we cannot go anymore inside it. So again, I want to contrast that with the power of Google engine that is great, and to balance with the openness of the Copernicus program. So as I told you, everything is free here, free and open. So accessing data is not a problem, it's free. Using the API is free. Processing the data on your own computer is obviously your own computer, so no additional cost from our side, no license issue neither. The only paid element is the infrastructure and the access to VHR data if needed. So that's the major difference, I would say, in between the Google philosophy and the Copernicus philosophy.
So if I just may,
I'm not fully sure. Sorry, Georgia, I complete with that. I'm not fully sure that Google is offering the same exhaustiveness of Sentinel data as we are doing.
Yes, I only wanted to add this part that, for example, we know for sure that Google Earth Engine is not offering Sentinel-1 SLC data. We don't know if they will implement it later, but there are some limitations on what can be done within that environment. But for sure, the benefits of ONDA, you will have them more analytically explained on the webinar, on the training on the 14-16 June. because we will show you for everyone, beginners and more advanced people who know how to work with Python and people who never worked before. We will explain you how you can request the data, access them, download them either locally or read them immediately from the online archive that only ONDA DIAS offers. So you will see that you will have several options, and I'm sure you will find the one that matches you the best. And of course, we will be there to reply to any questions that we'll raise after we explain you everything.
Then our objective is not to compete with Google. We are not trying to compete with Google. We are offering something that is different.
Yes, it's just not there fully yet because they're still developing.
Okay, thank you very much, Frank and Georgia, for your explanation of ONDA, of DIAS, of the services, and explaining also about what participants can expect in the training of this, which starts the 14th of June. Thank you all for participating in this informative webinar about the use of ONDA DIAS and the services. Thanks again, Frank and Georgia, for hosting it as well. And this webinar is recorded, so we will distribute it via our channels, also in the SKYS LinkedIn group, which is a closed group. And we hope to see you around the 14th of June. In case of any questions, you all have the email addresses of the SKYS core team. So in case of any questions, feel free to reach out and we will answer the questions as soon as possible. So thanks for now, and we hope to see you very soon. And yeah, let's use the Copernicus data to develop some new businesses and to add some value for society. Thank you very much. Enjoy the evening and see you on the 14th of June. Thank you. Bye-bye.
Enjoy the evening. Thanks to you. Bye-bye.
Thank you. Bye-bye.